Well, today we are going to see the next chapter of the subject, that is talking about the Heckscher Ohlin model. We are going to say that this is sort of a version of the previous model, the specific factor model. More specifically, is like a long-run version of this model. So this is, when we are talking about the specific factor model, it's like we are talking about the short run. That means that is when capital land is fixed. Well, here we're going to see something different. What is the main differences? So here we have three production factors, which are labor, capital and land, but now we are going to have just two production factors. And the main idea is coming from the fact that in the long run, the land that you have, it can be converted in capital. Imagine that you have a lot of land in terms of for producing agricultural goods. In the long run, I mean, when you have time, you can change your production. You have that land, you can sell that land, and then you can buy machines, building, and all of the requirements to the production of something else. So, because capital, when we are talking about capital, are those machines or equipment or buildings for the manufacturing things, also it's true that the land, when you're selling that land, you are getting money. And money is one of the main capital things. I mean, objects, okay? So money is capital as well as a machines or a building, okay? So that's why in the long run, instead of talking about three different production factors, we are going to talk about just two. Where land now is capital. Because with capital, you can buy land, and also with land, you can get capital, I mean money, and then convert that money in machine or any other requirement or equipment for the production of other things. So that's why we are going to talk about just two production factors. And this is just happening in the long run because it takes time, changes your land for capital. Well, in the other case, both production factor, capital and land were fixed, and that was because in the short run you don't have time to change from one to the other, okay? Just keep in mind that here we're talking about international trade, and in the real world we know that international trade is coming basically for differences among countries, but they are going to be in relative terms. So it doesn't mean that if one economy is the best at producing something, the two goods, because here we are going to talk about always two goods. If one economy is the best producing the two goods in absolute terms, it's not going to trade with other economies. No, always we are going to see how good is each economy producing each good in relative terms. So from observing one good in terms of the other goods. You can be really good producing both goods, but in one of them your productivity is even higher than in the other. So that's why we are observing both goods, and we are going to take decision when we are observing the whole information. So how good you are producing one good and the other, and then in relative terms in which one you are best, and then you are going to export that good and buy the other one, okay? So we were talking about differences. In the Ricardian model, we were talking about labor productivity differences, and that was coming from technology. Given the technology, we have the same labor that in one country is more productive than in the other. And that was because technology, sorry. But in the previous model, in the specific factor model, and in this model, we are going to talk about something more related to resources. So here we are going to see differences across countries in terms of their resources. In fact, we are going to use a lot two concepts. One of them is going to be the abundance, always in relative terms. So is the factor abundant, and this is something that is about the countries. When we are talking about here abundance, is when we are talking about production factors. So how many labor you have and how many capital you have. And always it's going to be in relative terms, okay? You can have a lot of labor and a lot of capital, more than in a different economy, so in absolute terms you are like the best, but we are going to see in which one of the two production factors you are even better, you are more abundant than in the others, okay? So always it's going to be in relative terms. We can talk about in terms of capital per workers, so in which economy we observe more capital per workers, or vice versa, workers per capital. So you can see now that we are comparing all the time one production factor respect to the quantity that we have from the other. So this is going to be a characteristic for countries. We are going to have different countries in terms of different production factor abundancy, but also we are going to talk about factor intensity. And this intensity is for the goods, it's not for the countries. So we are going to see that one good is going to be more intense, or it's going to use in more intensity one production factor, while the other good is going to use more the other production factors. So in that case we are talking about intensity, and it's the intensity in terms of input that you are introducing for the production of each good. Regarding the assumption of the model, though we are going to start with just one economy, and when we want to evaluate the effects of international trade, we are going to have two economies, okay? So we are going to have eventually two economies, two goods, so we are going to assume that each economy is able to produce two goods, let's say clothes and food, and also, as we said, we are going to have just two production factors that are going to be labor and capital, okay? So here we're going to have labor and capital. Because it's the long run, we don't have land in this case. Because eventually, as we said, capital can be land and land can be capital. You can see that this is 2, 2, 2, that's why sometimes we can observe this model like the 2 by 2 by 2, okay? Also because we are talking about abundance in relative terms and intensity also in relative terms, this model is also known as the factor proportion theory, okay? But now let's start with the main differences between this model and the previous one. So now, instead of talking about land, we are going to talk just about capital. So what in the previous chapter was land and capital, now it's just capital, as we said. So now, that is one of the main differences. Also, we are going to have two goods, like in the previous chapter. Let's say clothes and food. For the production of each good, we are going to need the two production factors, which are capital and labor. And in both cases are both production factors. The relationship is going to be positive, so that means as higher is the volume of labor, higher is the output or the production of clothes. The same thing for the case of capital. As higher is the volume of capital you are introducing in that industry, you are going to get a higher output. What is for clothes is going to be also for the food industry. More things. So now we have that capital and labor are going to be both of them mobile among the industry. So now we don't have a fixed production factor per industry. Instead of that, both labor and capital can change from one industry to the other. So one labor or one machine can be used for producing clothes or for producing food, because capital in the long run is money. So you can spend that money buying land or buying a new machine. Okay? So this is one of the difference respect to the previous model, because in the previous case, capital, it was fixed for one industry and land was fixed for the other industry. And labor was the only that was moving between the industry. Now, both capital and labor move across the industry. What about in terms of country level? It's going to be fixed. So that means its economy is going to have a fixed amount of labor and a fixed amount of capital. What is the thing that we are going to observe? we are going to see that even both industries are going to use both production function, the intensity of each production function in each industry is going to be different. In this case, for instance, we are going to observe that globally the food industry, so I'm using the F for food and the C for clothes, the food industry is more capital intense, because if we gather for the whole capital that we normally use in that industry over the whole labor that we use in that industry relative to the other one, relative to the other industry, we observe that the amount of capital per worker is higher in the food industry than in the cloth industry. Of course, we are going to get just the opposite in terms of labor. So if we put here labor in the cloth industry and capital in the cloth industry, is going to be just the inverse, okay? Labor in the food, capital in the food. So here we are saying like the food industry is more intense in the use of capital or capital per worker, while the industry of cloth is more intense in labor or labor per capital. So as we said, the output of the production depends on the production function that you are incorporated or allocated in each industry. So we know that as higher is the labor and the capital in the industry of food, higher is going to be the output in that industry, and the same thing in the cloth things. But now let's see the difference between this model and the Ricardian one, and this model and the previous one, the factor specific model. So when we were talking about the Ricardian model, we just had one production factor that was labor. So in that case, as higher is the amount of labor, it was better, higher is the output. So because we didn't have capital, the productivity of labor was always the same, because the production just depends on labor. So more labor, more production, and always in the same proportion. We didn't have any kind of diminishing marginal returns of capital, because we don't have machines to sell. Production is just the input of labor. More labor always is more production in the same proportion. In that context, we also know that the productivity depends on technology, and in fact we were talking about the unit labor requirement. So you remember it was something like that. A unit labor requirement for each industry always was for labor, because we didn't have any production factor, so that's why we didn't put here L, because we know that in that context it just can be labor. And it was for two industries. For instance, it was in the case of wine, and in the case of cheese, I think. So in that context, we were talking about that unit labor requirement. That meaning was how many labor I need to get 1 unit of output. So for instance, if this was 2, the meaning of that was, if I want to produce 1 unit of wine, I need 2 labors, okay? When we were talking about output or production in the specific factor model, in that context, we have 2 production factors. In fact, we have for one industry labor and capital, and in the other case it was labor and land. The problem there, it was like the thing that capital was fixed and land was fixed. So each industry were using the whole amount of the specific factor of production. So in one of them it was capital, so that means the industry used the whole capital of the economy, and the only thing that could change was the amount of labor. While the other industry was doing the same thing, but using land, the whole amount of land in that economy, and the only thing that could change was the amount of labor. The problem of having one production factor fixed, it was that as higher is the volume of labor that you are introducing, that labor has to share the fixed production factor. So in one case it was machines, capital, and in the other it was the land for the agricultural one, right? So that meant like the missing marginal returns of labor, given the fact that fixed capital didn't change because it was fixed, and land the same thing. Here is going to be something different, because in this case we have two production factors, but both of them can change from one industry to the other. So we are going to face in a certain way that the missing return to scale, but not so much, because the amount of capital and the amount of land, that now is capital as well, can change. In fact, we are going to talk about, again, labor and capital requirements. But it's not going to be so requirements, because now we have that we can choose. So it's not going to be something that you really need. Now the production of one good is not in the same way as in the Ricardian model. In the Ricardian model, in this example, if I want to produce 1 unit of wine, the only way was incorporating labor, in fact 2 units of labor. But now, for produce more of wine, let's say that is food, I can use both things, labor and capital. And there's going to be many possible combinations of labor and capital that is going to give me 1 unit of food, let's say wine. Okay, so that's why we are not going to talk about requirement. It's use, because I can use both of them to produce 1 unit. So now when you see these terms, it's going to be, it's not going to be the unit labor or capital requirement. It's going to be the unit of capital or labor used. So it's the capital used to produce 1 unit of clothes. That also has to be connected with the labor or labor used for producing 1 unit of cloth. You see, now we are not going to talk about requirement, because you can combine the production factor to get that output. There are many possible options of combination to get that one. The same thing is going to be for the other industry. So if here we have C coming from cloth, the F here, sorry, this is an F, it doesn't seem, but it's an F, it's coming from the other industry, which is the footwear. As we said, now we don't have a unit labor requirement or unit capital requirement. It's used. So you can choose what amount of labor you want and what amount of capital you need for producing 1 unit of your output. What is then going to be that variable that is going to determine how many units of one production factor you use and how many units you are going to use from the other production factor? Well, the variable that is going to be behind that decision is going to be the price of each production factor. If I see that the relative price of the relative price of labor, which is weight, is higher or is increasing respect to the cost of buying capital, I'm going to use more capital, and vice versa. If the price of capital increases more than the price of labor, I'm going to use more labor because it's cheaper. So that's why it's going to depend. Now it's not requirement, it depends, and it's depending the price of each production factor, which are determining the cost of production. Now we are going to use a numerical example to get the first approximation to the PPF. So, because we don't really know which combination is going to be used for the production of each good, so in this case, forget about the number for a moment. We don't know how many units of capital and labor is going to be used for the production of 1 unit of clothes, and the same thing for 1 unit of food. We are going to see all the possible combinations, and that is going to be the PPF. When you are combining all the possible combination of labor and capital, given the amount of labor and the amount of capital that you have in your economy, because those variables are fixed. So, and that is going to be the PPF curve, okay? So now we are going to start just giving 2 possible values for each economy, 2, 2, 3, and 1. We are going to see the PBF, but it's just going to be one of the many possible points of the PBF. Okay? It's going to be, as I said, a general approximation to the PPF. So we are going to take just some points of that PPF, and then we are going to drop the general PPF. So here we have that for the cloth industry, this industry has decided, given the prices of capital and the prices of food and the characteristics of that industry, that is going to use 2 units of capital and 2 units of labor to produce 1 unit of cloth. Here we have the same, but for the food industry. So, given the prices of capital and labor, and given the characteristics, so the intense use of capital and labor of this industry is going to use 3 units of capital and 1 unit of labor. So, just making a simple division, we are going to be able to observe which industry is more intense in one production factor and which one is in the other one. So here we have, for instance, unit used capital in the cloth divided the units of labor in the cloth industry. So this division is equal to 1. Here we have capital 3, labor is 2, which is higher than 1. So from here we are able to see that what is more capital per worker is here in the food industry. So food is intense, or at least relative intense, in the use of capital respect to the other production factor, which is labor. Now if you make just inverse, you are going to get that cloth is relatively intense in the use of labor. Okay, now we are going to give you some data about the amount of capital and amount of labor in these economies, and we are going to get the first point of the PPF. Now we are going to consider that this economy has this fixed capital and this fixed labor. So in the case of capital, it's 3,000 and labor 2,000. So given the previous data, we had that in the cloth sector, the amount of capital that they decided to use was 2 per unit of cloth and 2 units of labor per unit of cloth. In the food sector, it was 3 units of capital per unit of food and 1 unit of labor per unit of food. So that was the unit production factor used given the prices of each production factors. Now we are going to face this with the reality of these total resources. So we know that in the case of capital, as maximum, this economy can use 3,000 units. We also know that for each unit of cloth, we use 2 units of capital. And that is the thing that we have here. So, because 2 is the number of capital that we use per unit of cloth, the total amount of capital that we are going to use in the cloth industry is equal to 2 times the number of units that we are going to produce. So if we just want to produce 1 unit of cloth, the total amount of capital in that industry is going to be 2 times 1 is 2 units of capital. If we want to produce 2 units of cloth, it's going to be 2 times 2, 4 units of capital. Also, we know that we are going to use capital in the food industry, more specifically for each output or production or quantity of food, we are going to use 3 units of capital. So if I just produce 1 unit of food, I'm going to use 3 units of capital. So this is going to increase, and this is going to increase as higher is then the amount of each good that we produce in each industry. We know that as maximum, the total amount of capital that we can use is 3,000. So it can be smaller, lower, smaller, or equal to this value. but never higher, because we are in a closed economy and that is the amount of capital that we have. The same thing for the case of labor. We have 2,000 units of labor in this industry. We know that given the prices of labor and capital is going to use 2 units of labor. It depends on so the total amount of labor that the industry is going to use depends on the quantity of clothes that it wants to produce. And the same thing in the food industry. In this case, it's going to use just 1 unit of labor. So if we increase in 1 unit, if this is 1, total use of labor is 1. If this is 2, is 2. So that's why we can take off this 1, because it's the same value, right? So here we have the combination of all the possible combination generally that can be produced or can be generated given the amount of capital and the amount of labor that we have. So now we are going to draw these 2 lines, and then we are going to see which combination of output in the cloth industry and in the food industry is the best one, is the optimum. Okay? Because as I said, here we just have one possibility of combination of capital and labor in each industry. And given that combination, we are going to see the output that is the most efficient, and that is going to be 1 point of the PPF, because the PPF is the combination of the production of the 2 goods, clothes and food, that is given to a limit resources, a combination of resources, and when you are using them in the best way. Now we are going to see all the combinations that are possible of producing in each industry, given the 2 production factors that this economy has. In fact, we are going to start with the capital case. So we are going just to considering the production combination possibility given the capital that this economy has, and also given the unit usage requirement of capital in its industry. So for a while we are going to forget about the other part. In fact, we know that because here the variables that are the quantity of clothes and the quantity of food that you can produce, they are variable because it's not a fixed combination. There can be many possible combinations. That's why they are variable. These 2 variables, we know that they are in a linear curve. Why is that? Because they are just multiplied by a number, but they don't have any kind of power here, that these kind of things make that the function is going to be like sort of a curve, or neither they are dividing, but they are dividing. So they are a number over the variable that also is going to generate sort of a curve. But always we are going to be in a context of a line in this case, okay? In this kind of production limitation of production restriction. So you remember that this is the total amount of capital. Here we have the number of capital that you are going to use for produce 1 unit of food. So as higher is the number of food, you are going to need more capital, because this is capital per unit of food. And here we have the number of capital that you are going to use per unit of clothes that you are going to produce. Because we, as I said, we are in a linear or straight line, we just need 2 points. With 2 points you can connect the points, and then you're going to get the whole function, but now graphically. And which kind of graph we are going to be working? In the typical one of the PPF. So here we are going to have the production of 1 good, and here the other one. Here is clothes and here is food. To make things easier, I'm going to take those points which are in the strain cases. So when they are crossing one of the 2 axes that we have. They are easier because it's when you are assuming that the production of 1 good is 0 in its case, and the other in the opposite case. To do it even easier, I like to take this general function and isolate its possible production. Here is for the case of clothes, and here is the production of food. How is the way of isolating a variable? Well, we'll take each element of one side to the other side, and we start always from outside to inside. So here in this case, because we want to isolate the production of clothes from outside, this is more far away than the number 2. So that's why I'm going to start from that element that is more like outside. This is with a positive sign here, so that means go with the negative sign to the other side. Now continue with the next element, which is a little bit closer. It's the number 2, is multiplying, so it goes to the other side of the expression, divided. In the case of the food production, it's the same, so here is the one that is like more far away. So it's with the positive sign, go with the negative, and the number 3, which is multiplied, go divided. Now, I'm going to put here a 0, and then I'm going to have the production of clothes when you are using all your capital in producing that good. So the other 0. Graphically, so production of food, where is that? It's here in the vertical. Keep in mind that 0 is here, so if this value is 0, it's because it's here. As far away is from the 0, it's because higher the value, okay? So when this is 0, the production of clothes is going to be 0 times 3 is 0. 3,000 over 2 is 1,500. So that is going to be the quantity. 0 here. We are not going to be in the vertical because it's 0, but the horizontal, where is the production of clothes, is going to be 1,500. So I'm considering this point. Now the next point is when this is 0, because this is in the horizontal. 0 is not in the right side, neither in the left side, it's just here. So when this is 0, we are going to have in a point just in the vertical, which is going to be 3,000 over 3 is 1,000 here. Once I have this point and this point, I just have to make this line. So the line is all the possible combination of the production of clothes and food that are possible given the quantity of capital that this economy has, given the unit usage of capital in each industry, and without considering the fact that you also need labor. Now we are going to do the same line, but when we are talking about labor. We know that the total amount of labor is 2,000, that the food industry uses 1 unit of labor per unit of food that you produce, and 2 units of labor per unit of cloth that you are producing. So we do the same thing, so isolate each variable, and then we are going to draw the new line here, just considering now all the possible combination of food and clothes that are feasible when we just considering the labor that we have. So here, when the food is 0, food is in the vertical, so the point is going to be in the horizontal, and in fact it's going to be 2,000 over 2 is 1,000 here. Now the other case, when clothes is 0, you are not producing 0, so you are just here, not in the right side, never in the left side, because that is negative production, so you are going to be here. Now just in the vertical, take it that here it was 1, that's why here is like dividing 1, so it's not dividing. It's 2,000 because a number times 0 is 0, so the production is 2,000, is here. Now I have the 2 points. So I have again all the possible combination of outputs that are feasible, and also they are efficient. Well, not all of them. Which one is going to be the possible and efficient? Is going to be just this one. Of course, that point is the point in which the combination of output in the cloth industry and in the food industry is the same in both cases. All of them here are feasible when we are just considering one production function. Are efficient in that production function because you are using the whole production function. So here, when you are using all the capital that you have, here's when you are using all the labor that you have, but feasible is just this point. Why is that? Because here we have a quantity that is possible in both at the same time, when you are just looking capital and you are just looking labor. Now let's analyze this graph in a deeper detail. So we have here that, as I said, these are all the possible combination of output when we are just considering capital. Here was when we just was considering labor, and this was like, let's say, like the best point in which you are using a labor and capital, and the output is the same. How is the way of getting that value? You don't have to know how to get that value, but it's easy to do it. It's when the quantity produced in the food industry is equal, considering both equations. So food here is, in the capital case, is here. Food in the land case, in the labor case, is this one. So when you put this equal to this, when it's equal, you are going to get the quantity of cloth where both equations are equal. So for the other case, when the quantity of cloth, just considering capital, and here just considering labor, meets this equal to this, you are going to get that production of food that is the equilibrium as well. Just considering that we are using the whole resources that we have, okay? So it was two unknown variables and two equations, so it's really easy to get that value. So you can do it, and you're going to get that. For the case of the food, you are going to get 500 units, and in the cloth, 750 units, okay? But that is not important now, as I said. The thing that I want to show you now are different aspects. On one hand, if you remember the cloth one, it was the sector in which the intensity of labor it was higher than the use of capital. We can see that labor it was the blue line. So in that case, you see that the amount of that good the cloth is produced is smaller. In this case, given the fact that the total number of labor is the same in both industry, this 1000 is smaller than this 2000. How is that possible? Because this industry uses a lot of labor. So given the same amount of labor, if that amount of labor is just allocated in this industry, it's going to produce less than if that amount of labor is allocated in the other industry. Also, I'm able to see just the opposite in terms of capital, because this industry was capital intense, so that means that the unit labor usage of capital in the food, let's see, capital here, food is here, well, it was this 3 number, which is higher to this 2 number. So that means that this is going to produce less than the other one when we are talking about the green line, which is capital. But that is not really important, it's just a thing that you can observe, okay? The important thing here is the fact that when you are in a point which is different to this one, you are going to observe that the opportunity cost is not going to be constant. In fact, we can start just analyzing, for instance, all these values from here to here. Here we have the production of food. When we are just considering the capital that the labor that we have, we can produce 2000 units. But when we are considering the green, which was the capital, we are just able to produce 1,000 units. So that means at the end of the day that if we are here, there's going to be a lot of labor that we are not going to use because we are not able to produce that amount of food. It's not possible. Given this value, this is the maximum number of food or units of food that I can produce given the capital that I have. So all these units are not possible and they are associated with labor. So it's like we have labor that we are not using. The same analysis can be done here. Take care, the minimum number is going to be like the restriction that we face. Though, if I just observing labor, I'm able to produce 1,500 units of clothes. If I also considering, sorry, that was for capital because it's the green one. If I'm also considering labor, the blue one, I'm just able to produce 1,000 units. So it's not possible to produce all of this. And all of this is associated with capital that I'm not going to use because it doesn't make sense. Now I'm producing both goods, just considering both production function. So it doesn't matter if I have a lot of units of capital, if I have a sort of restriction in terms of labor. So all of this is not possible, okay? This quantity is not possible, this quantity is not possible. What is going to be the possibility production function? So that's PBF in a certain way because this is not going to be the final one. This is a PPF in the case in which we have this unit used labor for labor and for capital. Here is for capital and here is for labor, the 2 and the 1, the 2 and the 3, which are for a while fixed. But we know that in this model that can change, okay? But we are going just considering these extreme cases and then we are going to generalize the whole results of this thing. So we know that possible is this point, of course. In fact, in that point we are using all our resources, capital and labor, but also are possible this one. The green line was for capital. Yeah, all of these combinations were possible when we were using all our capital, while the blue one was when we were using all our labor. The problem of this is, a point like this is, well, this quantity, this point, well, this quantity, here we have the quantity of food, this quantity is possible, and when we are producing food, this one, given this one, this is not possible when we are producing clothes. Instead of that, when we are producing clothes, the output that is possible is this one. How is that possible? Because for producing clothes, we also need this amount of, to produce from here to here, we need like more capital. This is the output that we can get. This one is the output that we can get if we just considering labor, the labor that we have, given this output of food. But given the capital that we have, if this economy is producing 1,000 units, well, 90, let's say 90, okay, 90,000 units of food, if this economy is already there, is producing those units of food, the maximum amount of clothes that this economy is able to produce is here. And it's not here because to get that value, this economy needs more capital, because this restriction is coming from capital. If we have more capital, we can produce more, so we can move to the right side. But we are not in that case. This is just possible when we are considering labor, but keep in mind that you need not just labor, you also need capital. So, and the capital, the restriction is coming in this case from the capital. You don't have enough capital to produce this amount when you are already producing this. Something similar is going to happen in a point, for instance, like this. Okay, you can analyze that thing in both sides, from here or here. Let's use the same example. If we are producing this amount, I don't know which one is, let's say 400, the maximum amount that you can produce of cloth is that which is equal when you are considering labor and capital. Here is when you are just considering capital, because it's the green one. Here is when you are just considering labor. So that means this is not going to happen never, because you don't have so much, let's say, labor to produce this amount, though you have so much capital to produce that amount. Instead of that, this is going to be the production, because it's possible. The problem of that point of production when you are already producing this one is that there's going to be part of the capital that you are not going to use. Okay, that is the problem here. When you are considering, for each case, you are going to see that when you are considering the production of one good and you want to see what is going to be the production of the other good, the problem that you are going to face is that part of the capital or part of the labor is not going to be used. Though you have the possibility of producing more, just looking that production function, because you also need the other one, you are not going to be able to produce that amount. Okay? So that's going to make that the shape of the PPF here is not going to be a straight line. It's going to be something like this, this and this, because these are where both curves meets. So it's possible. As I said, this is not the final PPF, because here we are assuming just unit usage of capital and labor, which is fixed, and we know that that is not going to happen. Instead of that, we are going to have many points like this one, where it's just perfect. You are using all your resources. And how is going to be then the PPF? Well, this sort of PPF is going to give me the clue as how it's going to be the final PPF. And in fact, the thing that we are observing here is that the slope here and here is different. Here is steeper than here, so the opportunity cost, which is the slope of this curve, the opportunity cost of clothes is higher here than here. So this was just one case when we are going to have all the possible combination or use of labor and capital in each industry. The PPF, the actual PPF, also has to have a slope that is not going to be constant. In fact, it's going to be flatter here and steeper here, like is this one. But instead of just one line and another line, it's going to be in this way. You see, like both. More like a curve, right? So here we have our final PPF, okay? So you can observe that it's not a constant line. Instead of that, it's going to be both, right? So that is talking about how is the opportunity cost of producing more clothes in this case, and that opportunity cost is increasing. The reason of that, if you keep in mind the previous PPF, which was like two lines, it was coming from the fact that even given the fact that clothes in this case it was labor intense, while food it was capital intense. When we are in a point like this, in this side of the graph, is when we know that this economy has a small production, so that means that the inputs in that industry is small, both in capital and in labor, while in the other industry, which is producing a lot, most of the capital and labor is allocated there. So the increase of the output or the production of clothes in a point like this, so if this increase, it's going to mean, or it's going to involve the allocation of more workers in this industry, which was labor intense, right? So because this industry needs more labor per capita than the other one, when this is increasing its output, is because we are going to observe that a lot of labor now is in this industry. Keep in mind that in a point like this, where this economy is the one that is producing a lot and is also capital intense, we had a lot of resource of labor that is not used. So, introduce more labor in this industry is like cheaper, or it's not so expensive as introducing capital in this industry, which is labor intense. So of course it's going to have a cost producing more clothes in terms of producing less food, because if you want to produce more clothes, you also need more capital. But because you need a lot of labor, and in this case there are many labor that is not used, that means that that opportunity cost is relatively small. Okay, so you can see that the reduction of the output of this good is really small when you increase in 1 unit this output. In fact, the slope here, it was really flat. But when you are in a point like this, that means you are producing a lot of clothes. That means that this economy has most of the labor allocated here, right? Also, we have allocated some capital here. But if we want to even produce more, point like this, so that means that now we need even more labor. The problem of that is all this labor that is used is not really matched with all the capital that is used. In fact, for produce all of this, we use a lot of labor, but not so much capital. The thing that we are going to observe is there are many capital that is not used now. Okay? And the other industry is producing relatively small amount, so it's using less capital. So that is the main problem. When you are already in a case like this, introducing more and more output or allocate more input in this industry is going to have a higher opportunity cost. You can see that this distance is higher, so the reduction of the other output now is higher, because you already have a lot of labor here, and that labor is not using so much capital, because this industry is labor intense, so these workers don't need so much capital, and that capital is not used. So that is the main problem of introducing even more labor here. So that means you are taking labor from the other sector, which is intense in capital. That sector, those workers could use a lot of capital, but because those workers are here, they are not using so much capital as they could do it. So it's like there are many capital that could be used here in the food sector, but it's not used in any sector because the allocation of labor is basically here, where that capital is not really important, or is not so important as in the other industry. So that is going to involve a higher reduction in the production of the other goods. Okay. So, but the thing that I want you to keep here in mind all the time is the fact that the slope, well, always negative, of course, but it's not going to be constant, and instead it's going to be like increasing the slope. Here you have a slope, you can also put a line to indicate that, with a steeper value, right? This slope is higher than this one, which is flatter. So, but as you always, this is the PPF. So it's production possibility from here. It's possibility. But what is going to be the actual production of the economy? Well, the way of determining that is the same as was so far. And that means that is going to be the point in which this PPF slope meets the relative price of clothes. So, relative price of clothes is the price of clothes over the price of food. It's going to be a value, imagine that is 2, and here, of course, always in absolute terms. So here is going to be, for instance, the slope here is almost 0, the slope here is really high, let's say 20, and there's going to be a point in which the slope is just 2. So that slope is equal to these relative prices. So here is going to be the production of clothes, and here is going to be the production of food. In a closed economy, also we know that consumption and production is the same value in each good, and the consumption is coming from the point in which the ratio of prices also are touching or is touching the indifferent curves. So we should expect that the indifferent curves then, of course, must be over here. Okay, different curves. So we already have the production and the consumption in a closed economy, but the point here is not just getting those values, it's trying to know how it's going to be the allocation of labor in each industry and the allocation of capital. Because as you know, so far we've been talking about the unit labor usage. It's no requirement, so we don't really know how workers are going to be in the production of each good. And the same way in terms of capital, because it's unit capital usage, no requirement. So the thing that we are going to see now is how it's going to be this allocation of labor and capital, of the ratio of both of them, and how this is connected with the price of the two production factors, the price of capital and the price of labor.